Well, if you've seen my previous video of this device, it was probably only a matter of time before I made a video like this. So in this video, I'm going to be attempting to upgrade the storage on this Apple Developer Transition Kit. Now, if you haven't seen my previous video about restoring one of these Developer Transition Kit logic boards I got from China, I highly recommend you check out that video to see the full restoration process and repair of one of these boards. Now, in that video, I got this device working, but in order to do so, I only used a single 128GB NAND, and that, of course, you can see I have on there right now. Now, from the factory, these boards only ever came in one specific configuration, and that was the A12Z SoC, which you can see right there, with 16 gigs of RAM and 512 gigabytes of soldered onboard storage. And that was the only config these ever came with. You couldn't change the specs in any way, shape, or form when you got one from Apple for that 6-month period. But that I intend to change in this video. So, like I said, this device currently has a 128GB NAND installed, and what I intend to install onto this board are these two 512GB NANDs. Now, you might be wondering how I was able to find some 512GB NANDs for this board, and in fact, these NANDs that I've got right here are actually not meant for this board at all, but are actually intended for use on an M1 Mac motherboard. And based on some experimentation I've done, I've found that I can actually potentially get M1 NANDs working with a DTK. And the process to do so is actually a bit convoluted, but I will explain, of course, the entire process of getting these NANDs working on the DTK board in this video. Now, to start off with, I have done some testing, as I said, but I've only ever tested this method with a single NAND configuration. So I've tried it with a single one of these M1 512GB NANDs, and I was able to successfully get that working. Now, in the instance of this upgrade, these NANDs that I've got right here are brand new unprogrammed NANDs, like I said, for an M1 Mac. And there's a good way to check these NANDs to see if they're blank using a P13 or P15 NAND programmer. So I'm going to go ahead and get these NANDs inserted into that programmer. I'll show you exactly what to look for in the JC P13 or P15 software to see if they're blank, and then we'll go from there, and I'll show you exactly what I'm going to do to get these NANDs working on the DTK. Alright, so as you can see here, I've gotten the JC P15 programmer out here, and yes, I did upgrade from my previous JC P13 programmer, but that was just because this one also supports reading BGA 315 NANDs, which I needed for some other projects. But this process will work exactly the same between both programmers. So, I've got the two NANDs right here, so let's go ahead and just put one in here and take a look at what the software shows. So you can see that the programmer detects it as a SanDisk SD-Reg JHIH NAND. And I should note that you can also use KICM229 512GB NANDs the same way, but I don't have any of those on hand at the moment. I only have these. But like I said, they are functionally identical. So if we go ahead and take a look at the software here, you can see that it says the hard disk has been detected and the hard disk has been bound to the general state. Now if you see that, if it says the disk has been bound to the general state like that, that means that the NAND you have inserted is indeed brand new, blank, and never used. So I'll go ahead and take this NAND out, and I'll put in the second one here and confirm that that one shows the same. So yep, as you can see there, that one says it's bound to the general state as well, which means both of these NANDs are indeed blank. So with that, let's begin the process of attempting to get these NANDs working on the DTK. Alright, so with our NANDs confirmed blank using the JC P15 programmer there, you might think we can just take these NANDs, solder them onto the DTK board, restore it like I would an M1 Mac with blank NANDs installed, and it would program the NANDs appropriately and just work. Well, unfortunately with the DTK, that is not the case. And I did find this during my experimentation, as I mentioned before, but what can program blank NANDs appropriately for the DTK is, of course, the A12Z based iPad. So what I've got here is an A12Z based iPad Pro motherboard, and this particular one is for a 12.9-inch iPad Pro. But what I found you can do is you can install blank M1 NANDs onto this board, program it or restore it as you would an M1 Mac, of course just with an IPSW for the iPad itself with iPad OS, and it, just like an M1 Mac, will program the NANDs appropriately. And once the NANDs are programmed appropriately with this iPad board, they work on the DTK as well. So that's really, really cool. Like I said, I haven't tried it with a dual NAND config, but it sure worked with a single NAND config. So let's get these NANDs reballed, install them onto this iPad Pro motherboard, and we'll see if it actually will restore successfully. Alright, as you can see here, I've gotten my reballing jig out and the two NANDs here. So let's just begin the process of reballing both of them. So of course, the first thing we need to do is apply the NAND to the back of the stencil here. Just like so. You can see all the pads are lined up with the holes there. And then we'll just take this little scraping tool with some solder paste on it, as you can see right there, and press it into all the holes. Just like so. And then I'm just going to take my hot air at about 300 degrees Celsius and then heat it until all the solder paste melts onto the pads. Alright, and with the solder molten, we just take the NAND off the bottom of the stencil. And we'll apply some more flux to it. Then heat it one more time. And with that done, we just need to repeat the same process one more time with the second NAND. And with that, they are now ready to be installed onto the iPad logic board. Alright, so as you can see here, I've got the iPad board up on the preheater. I've already got it warmed up here, so now all we need to do is apply some flux to the board, and then we can take our new NAND chips, which you can see are nicely reballed there, and solder them onto these pads. I'm going to apply a good amount of flux there. And then we'll just go ahead and take one of the chips. It doesn't matter which one goes where at this point because they're both blank. And we'll just place each one into position. And that looks pretty good there. So now we'll just take the hot air and solder each one on. Alright, so that's both NANDs soldered on. So let's wait till this board cools down. I will get it installed into its chassis because it needs a battery in order to restore, and then we'll restore it, and in theory it should just restore successfully. So with that, let's get this ready to restore. Alright, so as you can see here, I've got the A12Z iPad chassis out here, so now we just need to simply install the board. Now you don't actually really need to plug anything into it, except of course the USB-C connector right here, but it does need to be connected to the battery. So I'll go ahead and connect that and plug in the USB-C port there. And with that all installed, we just need to connect it to a Mac. Alright, so as you can see here, I've got my M1 MacBook Air out here, so we'll go ahead and simply plug the iPad in via USB-C. And as you can see there, it detects the iPad in DFU mode, which is exactly what we want. And in theory here, all we need to do is attempt to restore the iPad, and in theory it should just work and program those NANDs. So let's go ahead and open the iPadOS 17.5.1 IPSW here and attempt to restore the device. Okay, and so far it's looking good. And yes, that's a really good sign. It is indeed restoring. So that's really good. That means the NANDs are now programmed and it's happy with them. So now we'll just let this restore complete fully, and then in theory we should have some programmed NANDs that will now work on the DTK. Alright, and the iPad has been fully restored successfully. So I'll go ahead and exit that. And yeah, we are pretty much ready to go here. So now I'm going to go ahead and get the iPad board taken out once again. We'll get the two NANDs removed off of the board and then reball them a second time to prepare them to be installed onto the DTK. Alright, so before we begin removing the two NANDs here, now that they've been programmed, we need to make sure we keep track of which one is which. So on the iPad board, this one right here is NAND 0, and this one right here is NAND 1, so we're just going to label them accordingly. There we go. Now we can start warming the board up here and getting the NANDs removed. Okay, and now with the two NANDs removed, now we need to remove all the residual solder, get all the flux off of them, and then we need to put them in the programmer once again to write the correct serial number and MAC addresses for the specific DTK we're putting them onto. Alright, so the first step here, of course, is to clear off all the solder. Now we just need to clean all the flux off of them and get them in the programmer. Alright, so as you can see here, I've got the P15 programmer out once again. We've got both of our NANDs here. Now, technically, NAND 1 we don't even have to mess with at all, but NAND 0 is what we need to program because that's what has the syscfg data on it. So we'll go ahead and put it in the programmer. And now, instead of being blank, it should detect it as being programmed for that iPad. And yep, as you can see there, it says binding iPhone, iPad Pro 11-inch 4th gen, iPad Pro 12.9-inch 4th gen as well. They're both the same device, of course, so we'll go ahead and select that here. We'll try to query info. Sometimes it doesn't leave a syscfg. So yeah, as you can see, that time it didn't leave any sort of syscfg on there. So now we need to write just a dummy syscfg on there. So we'll do restore syscfg. Go find our syscfg that we want to use here, and I want to use this one right here, which is just from some other iPad. So it'll restore the syscfg there, and now if we query info, you can see that all the expected data is present. So now all we need to do is modify that data appropriately for the target DTK. So I've got all that data right here, and this is the specific serial number for that DTK, which I retrieved from the Apple FDR server. Again, if you want more info about that, you definitely want to check out my previous video of restoring and repairing these DTKs, where I give you all the info about that process. But for now, all we need to do is just write this data into the syscfg. So we'll start with the mode here. I'm not really sure what that is. We need, of course, the serial number, the MAC addresses, the board serial number, and the model number. And with that all entered, we just select Write Selected Info. And let's query that, make sure all the data we wrote is there. And that looks good. So now we need to select PCIe, unlock Wi-Fi to unbind the Wi-Fi chip. And now it says Wi-Fi is unlocked. So yeah, that's it. Our NAND is now appropriately programmed for use on the DTK. So let's get those NANDs reballed again and get them installed onto our DTK logic board. Alright, and now with the NANDs reballed, all we need to do now is prepare the DTK board to have them installed. Alright, so the first thing we need to do, of course, is remove the NAND that's currently on there. Then we need to remove all the residual solder. Clean all the old flux off the pads. And now we can apply some new flux to the pads. Then we can align and solder on our new NANDs. Now on the DTK, NAND 0 goes to this set of pads right here. And then NAND 1 goes on this set. Get those pretty well aligned there. And then we just heat them to solder them into position. And just like that, that's both NANDs successfully installed. Alright, so as you can see there, I've gotten the DTK all connected. I've gotten the USB-C connected to the MacBook Air over here. And of course I've got the power connected to the power supply. You can see the two NANDs we just installed right there. So let's go ahead and take a look at the MacBook Air here. And we'll turn it on, and in theory it should just boot straight into DFU mode. Okay, and it's in DFU mode. That's really good. So now is the moment of truth. So if we restore and it succeeds, then it likes the NAND and it'll work as a 1 terabyte DTK. But if it doesn't, then it does not like this config. So let's go ahead and restore a 11.2.3 Big Sur IPSW and see what happens. Okay, that's good. It sees the serial number that we programmed in right there. So that usually means it's going to work. Okay, we're in restore mode. And just like that, the restore is progressing. So that's really good. That means it's more than likely going to work just fine. So we'll let this finish and take a look at the final results. Alright, so as you can see there, the restore was completed successfully. So all that's left is to get it hooked up to a keyboard, monitor, and mouse and give it a final test. Alright, as you can see here, I've gotten the DTK all set up and ready to go. So let's go ahead and plug it in and see what happens. Alright, it chimed, which is a good sign. So let's go ahead and take a look at the display and see what happens there. And we've got video. And there it is. We're now in a fresh copy of macOS Big Sur. So I'm going to go ahead and get this set up, and then we'll take a look and see if it detects all 1 terabytes of installed storage. Alright, and there it is. macOS is all set up and ready to go. So let's go ahead and take a look at About This Mac. Go to storage here, and there it is. Look at that. 1 terabyte of detected installed system storage. So that is an awesome sight to see here. Let's go ahead into System Profiler here. Go to NVMe Express. And there it is right there. You can see it detects the 1 terabyte SSD. And the DTK is kind of funny. It has technically 2 SSDs, but one of them is just an 8.4 megabyte drive with iBoot on it. I just found that kind of funny. But yeah, there it is. 1 terabyte's installed and working. So let's go ahead and go into Disk Utility. And there we go. 1 terabyte's detected and shown there as well. So that has been the successful upgrade of this developer transition kit to 1 terabyte of onboard storage. Now, I know what you might be asking at this point, and that is probably why I didn't try doing this exact same process, but with the 1 terabyte NANDs instead of the 512 gigabyte ones that I used here. And in fact, I did actually try that myself off camera after I did this upgrade on a different DTK. And while those chips did work on the iPad motherboard, they did not work on the DTK for whatever reason. It just didn't restore on them, didn't like them at all. I don't know if it's just due to the iBoot version or something that's being used during the restore process. I'm really not 100% sure, but in this instance, 1 terabyte is indeed the maximum amount of storage that can be installed onto a DTK. So with that, I hope you enjoyed this video.